Whoops, I'm on screen. Hold on one second, and let me get completely on screen here. All right, and we'll back up into the corner. Okay, this is being filmed on November something. We've just come off our in the United States. They sit and laugh at us all. So we just came off. They're feckless, and, and I get all these things. Okay, I'll come a snowflake or whatever. 4 years in the rain. So um, Joe Biden for really, he's saying with your grandbabies, up with something new. You shouldn't have deserted the unions under Clinton. But anyway, that's neither. Do a quick review of this crazy stuff of using the, okay? So you're going to get a quick video here. I'm going to use the quiz or end of chapter. Get my face out of here. Here we go. We'll go back to my ladybug. Here, oh, Red Allen. See, I wrote down. So here we go. And I better turn. I keep getting my. So if you see little, that something that annoys me is I don't know how to turn off my text messaging. So you might get little text messages from from my wife or my daughter or whatever. And it doesn't matter. Okay, so here we go. What I was going to say earlier, and I kind of got off on the lecture, was we've had a cold snap here. I think it's because I'm working with Canadians. It's like 14 degrees in the second week of November. We don't get that very often here. In fact, we haven't seen 14 degrees for a long time. All right. Anyway, let's take a look at this. So remember, let's say something takes off at an angle of 30 degrees with an initial velocity in this direction at 30 degrees above the normal at, let's say 25 meters per second. If you look at Bob Beeman's run, he was really flying when he took off 10.1 meters per second. What did we calculate Usain Bolt at 10.4 meters per second? That's still quite a, but goodness gracious, especially if you notice in the video, he's partying all night. Hey, whatever it takes to relax, So anyway, 25 meters per second. And so here we go. So we've got the x component, v naught x equals what? And v naught y equals what? V naught x is where we find our range. But we can't do anything until we use v naught y to find the time. All right? So let's just get v naught x. Remember, v naught x for this case would equal 25 times the cosine of 30. And it would look something like this. I don't know if you can see this. I hope you can. Hope it comes out. So you can go, all right, 25 times the cosine of 30 degrees. That's 21.65 meters per second. And then v naught y is equal to 25 sine of 30 degrees, and that will come out to be 12.5. I'm a genius. I just know the sine of 30 is a half. When you do this stuff for a living, certain numbers you just know. 12.5 meters per second. So, what's going to be his final velocity in the y direction? His final velocity in the y direction. If this was his initial velocity in the y direction, you betcha, negative 12.5 meters per second. What's going to be his acceleration once he leaves the ground? You betcha. Oh, this is my freaking Outlook. We can turn. Oh my goodness, you just got all kinds of stuff. I just wanted to turn that sucker off. Quit. Go away. It's not. Oh well, it never does when I want it to. A is equal to negative 9.8 meters per second squared. Aren't you glad I can stay focused? I'm like Doug and Up, the little dog. Squirrel! All right. Anyway, so we're out here. So this is the kind of stuff you're going to have to be doing. Okay? And I'm going to actually take a picture of this and put this on the page also.